It's day 5 already, and we are having the second physics class. In this class, I'll be talking about scalars and vectors. I have a lot to discuss in this class, and I hope I'm able to do justice to them in the short period of time that I have. Now, let me quickly get into it straight up. I had defined some type of quantities when we started in our first physics class. I told us we have fundamental quantities and we have derived quantities. That is basically based on their existence, how they exist. Some exist on their own, and some they are derived from the pre-existing ones. So we said fundamental and derived. But now, based on their action, based on how they function, and based on how we perceive them, we want to categorize quantities in physics as well now as scalars and vectors. So take note that some of these scalars can actually be fundamental quantities, and they can also be what derived quantities. It doesn't matter whether they are pre-existing or they exist from something else. And vectors, they can also be fundamental, and then they can be what? They can be derived quantities as well. So categorization that we did in the first class was based on existence. This categorization is based on function, perception, how we treat them when we are solving problems. So what are scalar quantities? I'm sure most of you here would be able to define scalar quantities. And then the concept of physics is that there is always the impact of magnitude and direction. So let's say, for instance, I want to kill a bird. Permit me, I'm going to draw some bird now. So whatever it looks like, yeah, this is my bird. So this is a bird. Now, just just admit that this is a bird. That's all. Now I want to kill this bird now. So I'm the hunter. Now, if I carry a gun, yes, let's say this is my gun, and I want to shoot this bird. Now, of course, you know that a gun will do a great damage towards this bird. Now, if I there's a thing also called aiming. There's a thing also called aiming. Now, if I'm aiming this gun directly at the bird, then the bird should fly away immediately. But let's say, imagine that the gun, I'm aiming it in this manner. So let me just rotate that gun. I want to shoot a bird. The bird is here. And I'm aiming the gun like this. Then the bird should just remain where it is because the gun is not going to strike the bird. Sorry, the bullet from the gun is not going to strike the bird. So this concept of scalar and vector simply explain this. Of course, everybody should be scared if they point a gun at you because gun can do a lot of damage. That's the magnitude of what a gun can do. However, as important as the magnitude of what something can do, then the direction in which that thing is being done also matter as well. So, but for some substance, for some quantities, they don't necessarily have direction impact have any impact on them. While for some quantities, direction makes a lot of great difference in them. So to conclude this introduction, if I give you two options now, you are standing, somebody is here and they are carrying a gun, and another person is also here carrying a catapult, and this one is carrying a gun. Then this person, you are here, let's say you are here, this person is pointing their gun in this direction, this person is pointing their catapult in this direction. So who would you have shoot you between these two? The person with the catapult is pointing it in your direction. This person with the gun is pointing it just opposite your direction. So if you are to choose one of them to strike you, which one will you choose? I'll leave you to answer that question. So I've defined scalar. Scalar quantities are quantities that have magnitude, but they do not have direction. So meaning that they are only determined by their magnitude and no direction. So I'm not going to be spending too much time on that. So we have several examples. We have mass, Mass is a scalar quantity. Speed is a scalar quantity. Time is a scalar quantity. We have quite a lot of them. We have distance. So I would like you to check up as many scalar quantity as possible. But the one that I'm very, very concerned with are vectors. Vectors, these guys are guys that have magnitude and they are also affected by direction. And quickly, that tells us that there are three ways that vectors can actually change. So anytime you are dealing with vectors in the future, you should note these three things. First of all, since a vector possesses both magnitude and direction. So a vector can decide, you can affect a vector by changing its magnitude. So once the magnitude of a vector changes, then you have affected it. Another thing you can do is that you can decide to leave the magnitude alone and change direction. So what do we mean? Let's say you had a vector of 20 units, 20 of magnitude of 20. The vector can be changed to 25 or it can be changed to 15. With this, the vector has been changed. But let's say you maintain a vector of 20 and then initially it was going up. You can decide that, oh, this 20 now, I want it to go to the right. You can decide that this 20, I want it to go down. So this time as well, you have also been changing the vector as well. And the last thing you can do is you can change the vector based on magnitude and direction. That is, you are doing both. So for instance, you started with a 20 going up, then you can reduce to 15 going to the left, or you can catapult to 30 going down. So these are three ways that you can actually change the way vectors behave. These are the ways you can change the way vectors behave. So therefore, let's go into something called addition and subtraction of vectors. See, for vectors, they are easily manipulated. However, it can be very, very complicated when you reach some advanced level. And so I'm going to introduce you to what we call the unit vectors in the two-dimensional plane. In the two-dimensional plane. So let's say you have this represents the y-axis and let this represent the x-axis. So you have a vector in this direction. This is y. Every vector in this direction, they are always associated with something we call a unit vector I. And every vector in this direction, they are represented with a unit vector j. So if I give you a certain vector v, I can say the vector equals ai plus bj. Now, with these two vectors now, so what I mean is that a is in the direction of the x-axis and b is in the direction of the y-axis. That is basically what this represents. But I'm not going to be going into too much of this unit vector. I'm just going to be using the raw x and y axis. So there are different approach to resolving vectors. There are different approach to resolving vectors. Now, if you have vectors in this form and you want to do addition and subtraction, it's just as easy as saying that you are collecting like terms. So the I goes with the I's, the J goes with the J's. For instance, if this was V1 and I have a V2, which is a vector, let's say UI plus VJ, you can easily add the two of them. That means that A and U will add up together. So if you have vector V1 plus vector V2, that will be A plus U, A plus UI, then plus B plus Vj. You can also subtract them that way as well. So, but oftentimes vectors are not going to be given in this particular manner. So let's see different cases of adding up vectors and finding resultant vector. So quickly, let's go to what we call the resultant vector. Now, what is resultant vector? When we say we want to find resultant vector, you see, when several vectors are acting at a point, that is, they're acting on a particular body, there is always a net action. That is one action that shows the general effect of every other vector that is acting in that system. So we are saying that if this is a body and you have several vectors, vector 1, vector 2, vector 3, vector 4, vector 5, and you have all of these vectors acting on this thing, you will notice that you are not going to experience each of the action of these vectors individually on this body. But there will be one thing that will happen, just one thing that will happen. And that one thing that will happen is caused by the net action of all these vectors together. And that net action of all the vectors together is what we call resultant vector. Resultant vector. So how do we find resultant vector? So we're going to be considering different cases. The first one we'll be considering, the first case is the case whereby you have two vectors that are moving in the same, that are acting in the same direction. So if you have a vector v1 going like this, and you have another vector v2 going in this direction, and you want to find their resultant is definitely going to be the addition of the two of them. That will be the magnitude of the resultant, and the direction will be that common direction that they have. In this case, arrow right is this arrow is pointing to the right, so the direction of the resultant force will be sum of v1 plus v2 also to the right, and that is how you find resultant of two vectors moving in this, acting in the same direction. Second case, if you have two vectors and they are in opposite direction, you have v1 here, you have v2 in this place, then the resultant is always in this form, v2 minus v1. That is provided that v2 has the greater magnitude. Magnitude of v2 is greater than magnitude of what? v1. And that also implies that the direction of this resultant will be to the left, meaning that you have two vectors, one is acting to the right, one is acting to the left. If v2 has a greater magnitude, that implies that the resultant vector, which is v2 minus v1, is also going to act towards the left, always in the direction of the greater vector with greater magnitude. Let's go to the third case. The third case is when you have them acting perpendicular to each other. When two vectors are acting perpendicularly to each other, so you have vector v1 and you have vector v2. In this case, what we do is that we try to draw something out. The resultant is always going to be in between them, because if a vector is acting in this way, another one is acting in this way. So you can tell that the frame where the action will take place is going to be in between the two of them. So what we try to do is that we try to draw out, so let me clear the extras that I've added. So we try to draw out what the resultant vector is. And we use what we call the parallelogram law of resolving vectors. And what we do is that, see, for vectors like v1 in this direction now, if I maintain this direction, I can easily bring it here. So let me change. You can see it's not changing. All I'm doing is just changing its orientation. And as you can see, it formed a right angle triangle. So let me use a dotted line to represent that. So all I'm doing is bringing v1 here, and it has formed a right angle triangle. Oh, that's not a right angle triangle. So it has formed a right angle triangle, and what you notice is that here you have v1 acting up. This is the resultant, and this is v2. Note the arrows. You can see that it feels like v2 is going like this, completing v1. They are like completing a path. They're not negating each other. But the moment we get to the resultant force, the arrow of the resultant force is sending us back to where v1 and v2 are coming from. Take note of the arrow. The resultant vector will always have a change in direction if you are to follow a loop in that triangle. The resultant force will always have a change in direction. The two vectors that are being resolved together will follow the same, like they are literally completing each other and following a loop. So take note of that. So since this is a right angle triangle, we can easily find the magnitude. We can easily find the magnitude of this vector. So we have resultant equals square root of v1 squared plus v2 squared. That will be the resultant. And for the direction, it is arctan v1 over v2. Basically, arctan of the vertical over horizontal. By the way, there's also more to this direction, and there's another video on that which I will attach the link to the description of this video. So if you want to learn more detail about this resultant thing, you need to watch that video actually, because it contains a lot more detail. Because this 50 days of tutelage, there are some things that I will not be able to contain, I will not be able to say because of time. So I am limited with time. I don't want the class to be too long so that you don't get bored of it. But there is a video already for that. I'm going to attach the link to this video. So if you're interested in knowing way deep and you want to know way more about this concept, I'm going to attach the link to this video so you can check it out right away. Now, the fourth one we're going to be discussing before I finish this class is, by the way, if you have not been taking notes since, that is wrong. You know by now that it is very, very important. It is one of the very first thing that you should do is that you should get your notes. And like I have said, you should try to share this with your friend. Always like the video. Always watch everything and share, comment, and share with your friends as well. It is very, very important. That's one of the things that you can do to also help my channel as well. So the fourth case is the case whereby you have two vectors. These vectors, they are acting at an angle to each other. The angle is theta, but the angle is not 90 degrees this time around. So we also use the parallelogram law of resolving. Like I said, the resultant will always be somewhere right in their middle. So what do? Let's say this is V1 and this is V2. So what we try to do is that we draw a parallel line. So look at the way V1 is oriented. So I can draw a parallel line that looks just exactly like V1. So if I draw that line, this is going to be V1. So you can say that it completed this triangle. And this theta, I cannot say the theta was evenly divided into two. So if it was 50, I cannot say that 25 is here, 25 is here. You don't know. So this theta is useless as far as this triangle is concerned. By the way, this will be your resultant. And the next thing we do is that you want to find an angle, because you will always need an angle in this place. But if you know what we call corresponding angles, if this V1 and V1, they are parallel to each other, then this V2 is going to be a transverse line. Therefore, the entire angle here, which is theta, is going to be the same thing as the entire angle here, which is going to be theta. And that implies that this is a straight line. An angle of a straight line is 180. So therefore, this other angle is going to be 180 minus theta. So I have my triangle now. I can draw it out. So this is the triangle. This place is where the angle is. The angle is 180 minus theta. This side is V1, this side is V2, and this side is the resultant. So from here, you can apply the cosine rule. Now, to solve for r, that means that r squared equals V1 squared plus V2 squared minus 2V1 V2 cos 180 minus theta. Cos 180 minus theta. So this is what you do in this place. However, cos 180 minus theta is the same thing as negative cos theta. So therefore, this can be written as r squared equals to V1 squared plus V2 squared minus 2V1 V2. So this one will now be plus cos theta. And that is, so you can use any version of these two guys. So that's it for today's class. We're going to be continuing with this tomorrow. Make sure you are subscribed to this channel and make sure you are sharing this with your friends. I will appreciate if you share with as many of your friends as possible. I'll see you in the next one.